invited guests, faculty, colleagues, students, ladies and gentlemen. Very good morning, namaskar, and very warm welcome to today's function. We have come together here for a second year Anand Memorial Lecture, which was instituted by the Department of Physics in the year 2015. Before beginning today's program, it's my pleasure to request Professor Anand to welcome Dr. Sani, today's speaker with us. I will now request Chairman Dr. Devinder Mehta to present our bouquet to Professor Anand. May I request Mr. Prof to present our bouquet to Dr. Devinder Mehta. We would also like to extend a full welcome to Mrs. Sani, to Mrs. Sani and the kindly presenter. It's our privilege to extend Anand family, which is being represented by 3 members, Dr. Yugendra Anand, Dr. Indu Anand, and Dr. Shobha Sekhar. All are now requested to rise for Panjab University anthem. program, I would now request Chairman, Department of Physics, Dr. Dhirendra Mehta, to formally welcome the guests.
Good morning, everybody. Respected Mrs. and Dr. Vinod Singh, former DAE Homi Baba Chair Professor and former Director RF at Indore, Professor Arun Grover, Vice Chancellor Panjab University, Professor P.N. Patel, former Vice Chancellor Panjab University, esteemed guests, valued alumni of each department, and present students. It's a great pleasure for me to welcome you all to today's program, second VM Anand Memorial Lecture. All of us have gathered here to commemorate the memory of Professor Anand, the foundational head of the Department of Physics, Panjab University, after the partition of the country. May I take this opportunity to extend to all of you warm greetings on behalf of my colleagues in the Physics Department and myself. Special thanks are due to you all for gathering to contribute to this meeting. We are thankful to Professor Vinod Sami for agreeing to our request to deliver second PM Anand Memorial Lecture. He is speaking on a perspective on Physics Society leakages. Thanks to Dr. Jugendra Anand and his wife, Dr. Indu Anand, and Mrs. Indu Anand, Dr. Shobha Sagar, who have traveled all the way to Chandigarh to place this occasion. Dr. Shobha Sagar is from PJMER. This annual feature was started last year. It is being organized out of the government funds arranged by Anand family. Last year we named this auditorium after Professor B.M. Anand. First B.M. Anand Memorial Lecture was delivered by Professor Jaspal. He gave glimpses of growth of physics education and research in this part of India after independence. Professor Jaspal association with Professor Anand overlapped the period during which physics honors school of the Panjab University, Lahore, Pakistan shifted to the campus of the Delhi University Department of Physics in India. Professor Jaspal shared experiences of that period of living and learning in the middle of chaos and immense operation. Professor Anand worked during his study leave from 1950 to 53 on lifetime measurements of neutral pions at the famous particle physics laboratory at Bristol, England, under Professor C.F. Powell, a Nobel laureate who discovered a neutral pioneer using nuclear emulsion technique. After returning, Dr. Anand started developing the nuclear emulsion section for investigation of the properties of heavy primary cosmic rays and elementary particles. Professor B.M. Anand was responsible for establishing Panjab University's Physics Department in its present campus at Chandigarh in 1958 and initiating research activities there. All in all, Professor Anand set up meticulous high standards of teaching and research. He set the tone of excellence for the Department of Physics. Professor Anand was a strict disciplinarian who insisted on meticulous details. The particle physics research using nuclear emulsion and bubble chamber was vigorously pursued by a number of faculty members, Professor I.S. Mitra, Professor P.M. Choud, Professor B.S. Bhatia, Professor J.M. Kohli, Professor Suman Bala, Professor J.D. Singh, Professor Manjeet Kaur, and Professor M.M. Agarwal, Professor Vipin Bhatnagar, and very recently Dr. Lokesh Kumar. This platform gave opportunity to faculty members to participate in international collaborations. The group has grown from nuclear immersion laboratory to mega collider experiments. The elementary particle physics group that he set up in the year 1960 has done him proud by having participated in various major discoveries in the field. The D0 group of Panjab University actively participated in the Nobel Prize winning discovery of top quark in the year 1994 as a member of the collaboration at Fermi National Accelerators Laboratory. The group has participated in the recent discovery of Higgs bosons in Sun collider experiment. The discovery again has led to the award of Nobel Prize in Physics in 2013. The department has excelled in nuclear physics with the platform set by Professor P.N. Trehan and Professor H.S. Han on the experimental side, Professor R.K. Bansal and Professor R.K. Gupta on the theory side. For solid state physics, Professor K.K. Srivastava and Professor K.N. Lakshmi Naina set the pace in the experimental part, and Professor K.N. Patel and Professor Satya Prakash on the practical side. The physics department has national standing in the Center for Advanced Studies since 1988. Now it has entered the fifth phase of CAS. It is cast in nuclear physics, high energy physics, and condensed matter physics, both theory and experimental. It is a unique feature in itself. The department continues to flourish today owing to excellent foundation laid by Professor B.M. Anand. The department is running 2 honors school courses in physics as well as physics and electronics. At present, the department has student strength of more than 450 and more than 120 research scholars are pursuing for their PhD. In addition, the department is responsible for starting new courses in MTech microelectronics, MTech in nanoscience and nanotechnology, and MSc medical physics. Anand family must be pleased by seeing the fruits of the small plant nourished by Professor Anand. With this I close. Thank you very much.
Thank you, Professor Mehta. I will now request Honorable Vice Chancellor, Professor Anand to address the August session.
Mr. Pathak, Dr. Yogi Anand, Dr. Hindu Anand, so many of my old teachers, Dr. Vinod Sani, who was a hero when I joined TIFR, a graduate student, young students, faculty colleagues from the department, from the university, invitees from the respective institutions, ladies and gentlemen. This event is a very emotional occasion for me. So was it last year. Bringing back the memory of Dr. B.M. Anand and trying to trace the history of physics education in Panjab allows me to connect so many dots in my personal life. This is not an occasion to recall all those, but still I am just tempted to recall a few of them. I am born in independent India. I studied in a school which was in the backwaters of Delhi University, and so many of my classmates were children whose parents or fathers were professors in Delhi University, and that included Vijay Olak, son of F.C. Olak, that included Lalit Mohan Johari, son of Anand Johari, that included Rajeshu Gupta, son of H.C. Gupta. Karmeshu Gupta was also there. Also, the founder, chairman of CBSE, Mr. R.P. Singhal, his son was also in my class. I didn't know that my life journey would traverse in a way that again and again I would have occasion to meet people who would connect me to him and in turn permit me to learn my own heritage. B.M. Anand, who joined, we learned last year, the physics honors school in the year 34, but the teacher was already there at the University of Panjab at Lahore. The honors school was commenced at Lahore in 34 when Dr. B.M. Anand joined, but that got disrupted in 47 and it had to be recommenced. It got recommenced via a short journey at Delhi University, and the students of Panjab University had stayed in a camp where typically that is the area where I was born. I lived 12 years of my life there, and I could vividly sort of get back to my own personal life when Professor Yashpal was describing how they stayed in that camp area by students of Delhi University. While walking into the hall today, I saw this photograph which Dr. Anand had put of 1949. The physics students of Panjab University graduating out of Delhi University. And you can see there, there is R.C. Majumdar, there is N.C. Olak, there is Sarna. These are the people I have met later on as the time went by. The last 2 days I was sort of reading through a book which is the biography of P.S. Gill. P.S. Gill represents again, a bit of our physics history in North India, which started at Lahore, went through Aligarh Muslim University via TIFR and then ended at Panjab University. So, Dr. Anand did his PhD with Powell, working with on emulsions and neutral mesons. It is the same mesons on which P.S. Gill had worked at MC College, Lahore. But there was no connect between what he did, the kind of cosmic ray physics that happened at Lahore, and the cosmic ray physics that was commenced in India by Baba at Bangalore. And there is an emulsion which arrived at Panjab University via Dr. B.M. Anand. There is an emulsion that P.S. Gill was also pursuing and also doing at a regular Muslim University. And Professor Hans was a student, so is Professor Puri at some stage. And there are so many other teachers of ours who have gone through these different branches which have, when they were growing, they didn't know each other. There was a little overlap, but they have got connected, and today there is a huge overlap in the science or the research that is pursued, say, in the universities as research centers and the niche institutes of India, which were set up separate from the university network. But in the 21st century India, everything seems connected and is necessary to be connected. Because even after 100 years of physics, 100 years after the discovery of cosmic rays, we realize that we know so little of what is to be known. So, today's high energy physics, which is via the big accelerators, or, is going to tell us about all these connects, whether it is the gravitational waves, or whether it is the probes deep into the universe, via these huge telescopes, either of the optical kind, or radio telescopes, or the X-ray telescopes. All these seem to be probing the physics, which has a connectivity, which 100 years ago, when cosmic rays were discovered, and Einstein was writing his 5 papers, quantum mechanics was not known at that time. There did seem to be a connect. After 100 years of probing, we realize that there is not only a connect of all these things, we also realize that there is so much more to be explored, but maybe the physics community will be kept busy for all of the 21st century. There is so little is known in spite of all these things. So Manmohan is sitting here, we have lived 50 years of our lives, and I really envy all the young people behind that you would know a lot more than we knew while being here and growing with it for 50 years. And I can see what people like Khanna may be feeling, because when he worked with Okubo and when he arrived at physics department, we had heard of Kelvin Okubo, mass formula, fold wave, this, that, and so on. We were very excited about it. But looking back at it, it looks that very little was known. And its ramifications were also not obvious. Nobody could say how the physics would develop. After the initial work as the accelerators came into being. There is a cosmic ray, and there is emulsion, bubble chamber. These are lab-based physics. Lab-based physics became natural accelerator-based physics. So the accelerator-based physics is not just the accelerators here, but now there are probes which are in the outer space, whether it is the X-ray telescopes, whether it is space programs. Everything has a connection. The basis of all that is essentially physics exploration. So I am personally looking forward to listen to what Vinod has to say and tell us about, he says, physics and society. And it's the offshoot of physics that, the cell phone in our pocket is also an offshoot of physics. World Wide Web is also an offshoot of physics. Everything that we, it's all offshoot of physics. So I think 100 years, next 100 years are going to be very, very exciting. Why we may not be there for 3,000-4,000 centuries, but that's it. So, thank you, Vinod, for coming and offering us to speak about what is happening in the mega science on behalf of.
Thank you, Professor Prof. In the August gathering today, may I take you back for a moment? It was Professor B.M. Anand who, during his tenure as head of the department, brought the international academic standards in the physics department by way of appointing eminent faculty and taking initiatives to set up matching facilities, making it a tradition for generations to come. He was a great mind, a great visionary, who was never confined to the conventional boundary of an academic discipline. Today, we have come together to recall the excellence of Professor B.M. Anand in the most direct manner. We are fortunate to have with us an eminent scholar, a well-known figure in the domain of science and technology of India, Dr. V.C. Sani. After having completed BSc Honours from Delhi University, Dr. Sani joined 8th batch of BARC, Bioeconomic Research Center School in 1964 and topped his batch. He started his scientific career in 1965 from the Nuclear Physics Division in BARC. He worked in the field of lattice dynamics and earned his PhD in physics from Bombay University in 1973. Fellow of National Academy of Sciences, he is the recipient of several national awards and international honors. Just to name a few: Young Scientist Award, M.M. Chugani Award for Excellence in Applied Physics, Homi Bhabha Medal in 2006, which he received from the then Prime Minister, Dr. Manmohan Singh. He has held several key positions. He served as the director of Raja Ramanna Center for Advanced Technology in Indore, where he was a driving force behind setting up India's biggest particle accelerator, INDUS-2, and creating the 2.5 GeV synchrotron radiation source. He was also the leader of the BAE team, which facilitated the participation of Indian high-energy physicists at CERN in the Large Hadron Collider projects. He served as the chairman, Research Council, CSIR C. Pilani, Director as Physics Group of BARC, and member of the Scientific Council of Joint Institute of Nuclear Research, Lucknow. The list is by no means exhaustive. Today, he will be delivering the second B.M. Anand Memorial Lecture. I am greatly honored to invite Dr. Sani to deliver this lecture.
My mic is this side, it will not capture the sound vibration. First of all, a very good morning to all of you. And I'm humbled by a lot of emulation which is showered on me. I can assure you I don't deserve most of that. But I must say one thing. Seeing Professor Grover and seeing Professor Carter reminds me of so many old associations. But even more than that is the fact that I have my two sisters here, my Asi's daughter, Dr. Shobha Sehgal here, and my own sister, Anand. You may not know that soon after the partition, the various families were affected rather adversely. And when my Asi moved over to our place in Delhi, all of us grew up together. And Shobha Benji moved from Delhi to Amritsar to do her MBBS. But I can tell you, when my sister completed her master's in mathematics, which she taught and then went to America, they were the kind of role models. So all I can tell you, my young colleagues, you are very fortunate because you are associated with the Punjab University Physics Department. Something which was founded by people like Professor B.M. Anand. And I've been hearing stories from my brother-in-law, Dr. Yogendra Anand, how for many of them, with absolutely meager resources, it was more a pursuit of perfection to the best of their abilities. I think they took up various kinds of challenges. If you simply look at the list of publications of Professor Anand, You see, he was looking at the energy consumption for cooking, to looking at the lifetime of 50 using emulsions. Now, what can be a broader spectrum than that? Professor Devendra Mehta suggested that I give this talk. I approached it with a lot of humility. I was not sure whether I can live up to the expectations of this very exalted lecture series, which was inaugurated by Professor Yashpal. But then I figured out that I also have several bonds with the physics department of Panjab University, and I'll run you through some of them. First, Professor Grover and some of his batchmates, I recall several names: Ajay Sood, Mohanlal Bansal, P.D. Gupta, Rita Banerjee, and a whole lot of them who also joined the training school. Arun decided to go to Tata Institute of Fundamental Research. And these students, after I interacted with them, raised my awe for Professor Anand, because it was he who had groomed the program for the MSc students in the 50s. And I can tell you, at times, I was mesmerized by the ability of several of them. I've been fortunate to work with both Arun and Ajay Sood and also Mohanlal Bansal, who is no more. I can't think of students who are better trained than in any other place, because they could look at several things in such great totality that it was a wonderful experience. But let me also tell you some other associations which I have had with Panjab University. At some stage I helped the Board of Research in Nuclear Sciences, in fact pilot some project, and I remember in the 90s I at times made a trip to Panjab University when they were indulging in developing photon multiplicity detectors and so on, and I was having interacted with Professor Kohli and Bhatia and Manmohan and so on. A lot of people, Agarwal, they were the people who were actually trying to do high energy physics or high energy nuclear physics. That is a time my respect for the abilities of the school really shot up. Now I'm going to request you to be a little indulgent, because I feel more at home here in Punjab than elsewhere. And when you feel at home, you are tempted to speak your native language. So if I switch to Punjabi here and there, I would say, "Aithe main opera nahi feel karda." I may think that I better convey myself, more expressive, if I switch to Punjabi once in a while in between. When Professor Mehta said that you have to give this talk, so I was reflecting what can be a good topic. So I came up with this idea and perspective on physics-society linkages. And I have put a very brief abstract, a longer abstract has been circulated to you. If you look at the entire 20th century, I think physicists have really done cutting-edge research. I don't think, although there were people like, let's say, Sheshadri, who was the head of the chemistry department in Delhi University where I grew up, or T.N. Maheshwari, who was doing something in botany. And I think the physicists always stole the show. Now, it is rather a little unfortunate, because somewhere the nation seems to have lost that respect, which is absolutely essential. So my concern is, if you don't inspire people of the right kind, and my concluding slide will show you what my concern is at this moment. So I want to, in this talk, what I will illustrate is how, even as we continue our efforts on basic research, by fine-tuning our R&D programs, at times we can give something which is of direct benefit to the society. Because at the other end are the people from the public life. That is the style with which, so what have you done? They may not be able to see what is the connection between the discovery of Higgs particles, or for that matter the gravitational waves, and we have to actually amplify our signal and let them know, look, this is the way the technology develops, and that is how it impacts the lives of people. So I hope I will be able to convey some of that, and of course I want to thank both Professor Anand Grover and Professor Devendra Mehta for this invitation. Now this is a personal letter. When I was thinking how should I commence this talk, I happened to discover one of the old letters from Professor Anand, letter says it all. This is a letter which was written by him to us way back in 1989. He was on a trip to India. And he felt sick. He had come to Bombay. He had come with his grandson. And his grandson also was accompanied by his wife. So they decided to go and stay in a hotel. And then Professor Anand felt sick. And, we were cursing ourselves. We should have taken care of him and so on. And he was hospitalized, put in St. George's Hospital. My wife and I went there. And he said, no, I'm perfectly comfortable. But nevertheless, I think he could sense our anxiety. So the moment he moved from Bombay to Delhi, he wrote us this letter. I hope you'll be able to read this. It says, I'm writing to express my appreciation and grateful thanks for your kind help and advice during my hospitalization in Bombay. And to tell you the truth, this is one thing which I had preserved. And it's the summer of 1989 means it's more than 25 years. Okay? I treasure it because it symbolizes the extraordinary charm and affection that the man exuded. And I think there are a number of people who would have profited from it. In fact, I was looking at the booklet brought out last year, how Atul Murthu was hesitant, because he decided to switch and go to radio physics in Calcutta, then said, oh no, I made a mistake, I want to come back and join physics department, and the way Professor Anand handled that. Now, these are the kind of human stories which ultimately distinguish a good school from a bad school. If you have an administrative setup, नहीं कर सकते, वो नहीं कर सकते, किसी form ठीक line से नहीं पढ़ा, well, you can't expect something very great out of that institution. So if today, Panjab University, Chandigarh, and I'll share with you what are the kind of things which they have accomplished, is largely because of the seeding done by Professor Anand. Now here is a summary of some of his career. I want you to notice that he was born in the miracle year of physics in 1905. You remember that was the year when Einstein wrote his famous papers. So probably he was destined to do physics. And interestingly, on the centenary of Einstein's prediction about detection of gravitational waves, that experiment was also detected. It was in September of last year. Now I thought I don't want to read out each of these details, except that here was a person who finally was all through supported by state scholarships. And he used to be, in fact, somebody we looked up to. That is at a professional level. And at a personal level, he would in fact encourage everybody. And look at the kind of upheavals he went through in life. You get displaced from Lahore. You are a refugee, as Professor Yashpal said, in Delhi. Then you move to Hoshiarpur and so on, and eventually you create this huge institution which continues to go from strength to strength. And some of it was alluded to by both Professor Grover and Professor Vijay. So let me move to the next slide. This is a picture of Professor Anand when he was in Bristol. Now I want you to appreciate this point. From the early 20th century, all these names I have put down, Jagdish Chandra Bose, C.V. Raman, S.N. Bose, Rekha Saha, P.S. Krishnan, P.S. Gill, Kothari, Baba Saraway, these are all the people who did some research in physics in India. I have not included names like Chandrasekhar because he went away to UK. In fact, although he did pioneering work in the area of black holes. So you have to understand that it was this kind of a tradition in which Balmohan Anand grew up. And what was that tradition? You do something which people take note of. It is not that you do some mundane stuff, keep publishing something, nobody pays attention to it. So as I was thinking, what kind of thing I should actually, if we are having a lecture in honor of G.M. Anand, what would have thrilled him or what would have excited him? And I have here, in fact, this slide is just an extract from this physical review letters of week ending 12th February. It is published actually on the 11th of February. This is the first observation of gravitational waves from binary black hole multiple. I want you to take notice of 2-3 things. First, you may not be able to read from that distance, that they are trying to target a peak gravitational wave-induced strain which is of the order of 10 to the minus 21. The only thing you can compare it with is when Anand was trying to measure the lifetime of Phi-0 at the level of 10 to the minus 15 seconds using his emulsions. And if you multiply with the speed of light, you can see that his whatever vortices he was distinguishing were no more than something like microns apart. So one is really looking at not a needle in a haystack, it's a needle in a huge, huge haystack. Because this is a 1 part in 10 to the 21 means it is 1 crore of 1 crore of 1 crore. So just I want this idea to sink in. This is the kind of demand the gravitational wave experiment requires. And what did they find? They found that this was because of merger of two black holes at a distance which is 410 megaparsecs. 1 megaparsec is 3.3 million light years. So you multiply this 410, you will discover this is something which happened 1.3 billion light years ago. Okay? What is even more interesting, if you look at it has a total of something like 133 partner labs all over the world. 9 amongst them are from India. And interestingly, the news of gravitational wave detection was treated by Narendra Modi announcing his cabinet's approval for this 1300 crore Indian leg of the US-India collaboration for gravitational wave detection. So I think if something happens which is really noteworthy, even the politicians seem to take interest. I'll share something more with you. Now, this is my very brief introduction to gravitational waves. Gravitational waves were first predicted by Einstein in 1916 using his general theory of relativity. That there are wave-like solutions of his field equations. He concluded that gravitational waves are very weak, tiny transverse waves generated by a time-varying fast quadrupole movement of the source. This is a matter of technicality, which travels at the speed of light. But he also said that they will be too feeble to be detected. Later in 1930s, Einstein himself had reservations about the existence of gravitational waves. In fact, there is a very interesting correspondence when Einstein sent a paper to Physical Review, and Tate was at that time the editor. He said it has to go to a referee. Einstein was unhappy, and finally he said, I will retract this paper, either you publish it or Physical Review said, we can't change our editorial policy and so on. So a lot of interesting correspondence exists. But it was somewhere around 1960, serious efforts to look for gravitational waves were actually commenced. And the sensitivity of these search efforts has really improved remarkably over the past half a century. And I'll in fact take you to some of that development. Now, at a certain stage when I was sharing my thoughts with other people to say, am I on the right track or am I not? So I happened to send a few slides both to my brother-in-law, Dr. Anand, and his elder brother, Ram. And this was the comment which Ram made. And he said, inclusion of this topic of gravitational waves in the second Anand Memorial lecture is very interesting and timely. Because many of the technologies involved in the study of gravitational waves are very similar to those used in molecular spectroscopy. And he pointed out that when Raman effect was reported in 1928, the Panjab University team, mainly led by Professor Kishu and Dr. Anand, started to work on molecular spectroscopy. But interestingly, the equipment was not available commercially at that time. So they decided very high vacuum pumps, UV to IR sources, detectors instead of interferometers and optical components. They were indigenously developed in physics department. Now can you beat that? So in fact, this is the legacy which my young friend sitting at the back, that you have to carry forward. Okay, it's close to 90 years ago, if they ran into a situation, they were not saying कि ये अच्छा इंटेंट डालेंगे देखेंगे कब आता है. No, they in fact built their own ultra high vacuum or very high vacuum equipment because otherwise UV gets attenuated in no time. And so, now the 9 labs which I mentioned, this is Ayuka in Pune, this is TIFR, that their Center for Theoretical Studies, Chennai Mathematical Institute, RR-CAT, which I was associated, IIT Gandhinagar, Institute of Plasma Research, TIFR Mumbai, this ISER in Trivandrum campus and ISER in Kolkata. These are the 9 institutions. in that list of 133. Now, why are astrophysicists so excited about it? Professor Grover referred to it. A priori, you can say gravitational wave is something else. Doing astronomy in the area of gamma rays, and in fact, my colleagues are building a telescope in Hamle, which will be a gamma ray telescope. So it gamma rays in the range of 20 GeV. All this 30-meter telescope, optical telescope, and so on. These are different limbs. No, they may be different limbs. But if there are events taking place in the universe, there will be signatures in each one of them. So if you can have various techniques looking at it, looking at the same phenomena, then it brings you very close to the reality. In fact, it gives you a much wider perspective. So that is really the interest. Now, what are the kind of things you can generate gravitational waves? These can be triggered by cataclysmic events involving stars or black holes which travel at speed of light. Gravitational waves may be created even in early universe, and because merely by the dynamics or expansion of the universe. And these gravitational waves which are associated with cosmic gravitational waves, they could even discriminate cosmological models. Most of the detection is now dominated by laser interferometers, gravitational wave observatories. And these are the countries which are leaders in it. In fact, Germans and the Japanese sort of partially gave up, but the Americans persisted. And I'll tell you a little bit of story about it. This is the result. The last line, in fact, indicates the results are because of two sites in America, Livingston in Louisiana and Hanford in Washington. Now, the interesting story is the National Science Foundation in America, almost 40 years ago, told these guys, they were independently running their, this program. Caltech was running something, MIT was running. They said, look, you either join hands, if you don't join hands, you will withdraw funding. So naturally they were sort of, if you wish, this is fiscal pressure. And they managed together. So, I'll take a couple of minutes to explain to you what this slide is. These are the two places. This is in fact just United States of America. It's a picture of the globe. And these are the two sites. This is Livingston in Louisiana, and this is that Hanford Observatory site. Now what is done at each of these sites is there's a setup created like this. It's basically an interferometer. You start with a laser source. This is a beam splitter. It's like a Michelson interferometer. So you send the beam, part of it gets reflected, goes to the mirror here, comes back. Part of it is transmitted, it is reflected back. And then you essentially combine these two and look at the interference. You may not look at the pattern, you may directly put it into a variation in intensity. And eventually infer from looking at this data how much is the strain. Now if a gravitational wave were to come, which is, let's say, which is plane polarized, such that at a certain instant of time, it may elongate this arm and it will contract this arm. There will be a phase difference which will finally get reflected into the form of the light output of the photodetector. Okay? So you look at the variation in the output of the photodetector, then you will be able to estimate whether or not the gravitational wave did or did not. There are lots of problems. It's very easy to say this. The original Michelson interferometer at these two arm lengths was just about 30 feet each. Now, this is not good enough for gravitational wave experiments. What these people have done is, each of them is 4 kilometers long, but then to effectively increase the length of the arm, the light beam is made to bounce back and forth, 280 times. So it is not just 4 kilometers, it's 4 kilometers multiplied by 280 kilometers, 280 times. So it's 1,120 kilometers. Each arm is that long. And then you require, the more powerful the light source, the better is your chance to detect what is the change in intensity experienced by the photodetector. Now how did they do that? They said, let us use, I'll explain part of it. This is what they call as a power recycling mirror. Imagine that this mirror is like a one-way gate. It allows the light which comes from the laser, but it doesn't reflect anything back, and it's nearly 100% reflecting on this surface. So the analogy is like this. This recycling mirror basically lets in a lot of people get inside a, let's say, a hall, but doesn't allow them to get out. So after a while, the total amount of circulating power is not just 20 watt, it becomes something like 100 kilowatt. Okay? That is what pushes the sensitivity of this experiment even further. One more thing, in fact there are also some recycling details about the signal recovery and so on. I mean, you have to read each of those. There are 130 references and so on in that paper of ERL. And there are more than 1,000 collaborators in that experiment. Each one of them is a lifetime effort. So if there is perfection to be attained, this is one of the best illustrations of that. I neither had the time nor the competence, but I would urge any one of you who is interested. And I think that is the key issue. The kind of stability which you are trying to achieve actually empowers you to look at many other benefits. So when, let's say, National Science Foundation invests its money into this gravitational wave detection, it's not just that they are only targeting human lives. It may happen, it may not happen, that's a story. But they also are targeting an opportunity that the technology which is developed thereby has its spin-offs. Okay? And I think this is the part which must be appreciated, but brought to home to the leaders. Interestingly, our Prime Minister, in fact, this is the tweet which Modi has, hope to move forward to make even bigger contributions with an advanced gravitational wave detector in the country. So I think we should hold him to this statement of his and say, sir, what are you doing? It's not enough just to put 1,300 crores in. I think we have to create positions such that some young people do get enthused and interested. I think we should, in a diplomatic fashion, capitalize on the statement which he has made. So all that's partly diplomatic statements and so forth. But let me share with you what is the data which has been generated. This is the data at those two sites. This is at the Hanford, Washington, and this is at the Louisiana site. Now you can see they are almost looking very similar to each other. The only thing which happened was that the signal in Louisiana site came about 2 milliseconds earlier than the signal in the Hanford site. So they figured out that means the gravitational wave must have been from a source which was in the southern hemisphere, because that is how the Louisiana was hit first, and the Washington site experienced it a little later. So these are some details. I will not bore you through those. Essentially, they have tried to fit something to general relativity theory and then looked at what are the residual numbers. So you can see there is a fair amount of confidence, and they have in fact even put in what kind of possibility that it's a fluke and not genuinely because of gravitational wave, and that number is 1 in some more than 200,000 years ago. So I return to this point which I said in the beginning. Note that the whole thing lasted only from 0.25 seconds to 0.45 seconds. So just in 1/5 of a second, खेल खत्म. It is not that it prolonged for a while, and within that 1/5 of a second, what happened was there were two black holes which were spiraling towards each other. This is when their event horizons overlap, and this is finally when they merge. And in the bargain, they generated gravitational waves. And you can see it's perfectly sinusoidal thing. Only the period keeps changing. Okay. As I pointed out, the Louisiana site recorded it 7 milliseconds before, so the origin was in the southern hemisphere. And they essentially figured out the lower limit at which the signal was detected by this instrument. It was when the time period was of the order of about 30 milliseconds. And the ring down happened here when the two black holes had merged. So this is what basically, these were the inferences, and this has been analyzed. Some of the people from Tata Institute contributed to this theoretical analysis and so forth. The kind of demands which you made on those interferometers, the vacuum which is requirement, the vibration isolation, I think it's tapasya. And therefore, I would urge you to at and figure out whether you would like to contribute to something else. And I think we should tell the Prime Minister, okay, here is a young team. When we want to set up the Indian leg of this gravitational wave observatory, I think these are the people who should be associated. Okay, so this is the beauty that advanced LIGO has opened up a new door to astronomy. So not only you have photons, neutrinos, and ultra-high energy cosmic rays, but you can have gravitational waves to the list of astronomical probes. Now I want to share with you something because this is a little personal anguish which I have. At one time I chaired one of the committees for DSC on international collaboration. And Unikrishnan from DIFR had asked me whether I can help them get some funding. This was a proposal which the Australians were making, the Australian interferometric gravitational observatory. So I told Unikrishnan, okay, bhai, dekho, more than doing some paperwork, at least identify what is it which they need and whether you can do it or not do it. I mean, my experience with CERN activity surely showed me that we should make sure we get into a commitment after we can ensure that we will be able to deliver it. Unfortunately, of course, you can see here, David Blair sent a letter to Ranjan and said, will you forward it to Professor Sani, he thinks it is suitable. It is a long list. The amount was not very large. But tragically this happened when I was about to debate my office, and some of that momentum got lost. And Anand was not able to pursue, then there were some delays and so on. So essentially this was a premature death of this proposal. Otherwise there were some very interesting things. Again, looking at very, very similar things to what the experiment eventually succeeded. Now this is what that Australian interferometric gravitational observatory was. It's very similar to what I have explained. 2 powerful laser beams, 4 kilometers, again that Fabric-Barrow and the Michelson interferometer. They were targeting something like a strain of 10 to the minus 40. Now if we had gotten on board and that program had started, at least there would have been another observatory working in Australia. I understand this project was finally shelved. Now I must share with you here, this is a European effort. The European effort is even more gigantic. The effort is not have just 4 kilometers, but have what is primary goal of this laser interferometer space antenna is to apply an interferometer with a 5 million kilometer long arm length. Okay? And there are such gigantic challenges there to establish whether the technology will work or not work. They have a mission called ESA Pathfinder, and I'll share with you just a few results from that. Pathfinder actually has what is called a ESA technology package, and then there is a disturbance reduction system. Now I want you to understand the value of this disturbance reduction system. This was built by NASA's Jet Propulsion Laboratory. It uses micro rockets to control spacecraft position to within 10 to the minus 9 meters. So imagine something is sitting at thousands of kilometers and you want to pin it down to this. I mean, what is it which you are doing? They are targeting that kind of thing. Okay? And recently they did do the first, this is in fact a report from Nature which was published in March 3rd issue, which I just quote to you the final statement. This is actually a schematic of what this Pathfinder was attempting to do. Complexity of such an experiment carrying out millions of kilometers from Earth meant that skeptics doubted whether it could ever work in space. But the data sent back on 23rd February 2016 when Pathfinder began to use lasers to track the release tubes shows that it not only fulfills that requirement but exceeds them. Okay? So the next round is, yes, the LISA mission will go in another 2 years' time. Now, my purpose in giving you this sort of quick flavor of it was to share with you the excitement, and even if you do a challenging thing like this, the technological hurdles and the ingenuity which is required, okay, I think is almost similar to what Professor Anand displayed in his experiments at Bristol. And you have to contextualize everything. And I would now move on to the next slide, which is the Large Hadron Collider with which I was associated. Panjab University has played a stellar Now, there is a book which has been compiled by people in LSC. I'm going to cover of that picture because it is edited by Lyndon Evans, a friend of mine, in which he says that this is one of the biggest challenges to human ingenuity. The kind of difficulties which they have overcome in setting up the Large Hadron Collider. Again, that book must be, I'll show you the reference, and I would urge some of you, because it is more in a sociological context, but it must be read. So this is a picture of in fact, an aerial picture of Geneva, and this is the Large Hadron Collider ring, which is about 100 kilometers below ground. At this moment, this LHC operates proton-proton collisions, each carries 6.5 TeV energy, and this happened from last year. This story actually is quite old. It started with a MOU, which was a protocol agreement between Kando Rubia and P.K. Iyengar, which was written in 1991. And then Douglas Smith and Chidambaram agreed to a collaborative arrangement in Delhi on March 1996. And we used these two. So I will not take you through great details. I'll just share with you some of the hardware which we supply to the accelerator. There are not too many countries who contributed hardware to the LSC. It was Canada, Japan, India, US, and Russia. Okay. Of course, the European Union countries were involved. Now, the way CERN works in setting up the accelerator is a huge challenge. First, you have to write down the specification for the product which you want. Then you must ask people to develop a prototype. Take it through a qualification process. After it has been qualified, then you ask people to make a pre-series. And I will show you in the next picture. I mean, lots of things. These are some corrector sextupole, decapoles, magnetic test measurements. These are some quench heater protection supplies, local protection units, and so forth. So, in fact, I received a memento from Philip Lebrun. And this is a partial list of what all we did for them. I will not dwell much on it, except to tell you that it was something of the order of about 50 million Swiss francs. And our arrangement with CERN was that they will give us only 50% of the money. Okay? So if we contributed something with 100 rupees, they will give us only 50 rupees. But if we incur only 50 rupee expense, okay, then our expense and that remaining 50 rupees would be given to us in the form of a credit. And that's how we ended up with a certain amount of money in CERN's book accounts. And that was partially used before to send our people who were doing research and so on. And that is what Sujit referred to. So here is a picture with Robert Ayman, who was the Director General. And I had some understanding with Ayman to do even a little further thing after LHC. Unfortunately, that has sort of tapered off. So this is the book I was referring to. This is called the Large Hadron Collider, a marvel of technology. And this was presented to me by Evans, my friend Vinod, with thanks for a fantastic collaboration. Now, I would urge, I'll give that reference to you, Arun, and I think you should get a copy of that book and make this mainstream. Essentially, what is LHC? LHC is essentially a synchrotron machine. Protons are injected at 450 GeV, and their energy can be ramped up to 70 eV. LHC can also operate in the mode which there is a collision with lead nuclei, and these are those 4 detectors. India is involved in CMS and ALICE, and people in this laboratory know much more about the CMS collaboration. Since 2015, now the collision energy has been enhanced to 6.5 TeV. And because these collisions create huge energy densities, similar to those at the time of Big Bang, that machine the media started calling it Big Bang machine. Now, the detectors have to face an event rate of the order of millions per second. So every second, there are billion proton-proton inelastic collisions. The debris, you have to discriminate the data, pick up only that which is new stuff, because you don't want to look at the old stuff. So there's a lot of sophisticated technology generating petabytes of data every year. And I was thinking, if physicists have that ability, maybe we should also entrust that how do you your time. I won't spend more time on it. I'll just say that the CMS and Alice detectors, what are the contributions we also have for the LHC grid computing, and there are Tier 2 sectors at Mumbai and Calcutta. I don't know what is the latest status about upgrading one of them, which was supposed to happen in Tier 1. This is a picture of, you can see Panjab University featured in so many places, in the tracker, the Baghdad. The pre-shower was done by DARC, and again, this hadron calorimeter was again done by Punjab University. There are a lot of people, but I would assume that there are 400 students who have gone to Punjab University over long service time. So what is the outcome of it all? This is the experiment. This was the data generated by LHC. It's essentially trying to look at whether there is a local probability it is by fluke or it is generally if the Higgs boson has a mass of about 125 GeV, you can see the prospect that it generated a fluke signal that is something only of the order of about 3 parts in 10 million. So it meets that 5 sigma criterion. So this is the one which led to the conclusion that yes, the Higgs boson has been seen. This is the production, this is technical, I did not spend time on it. This is, when the protons collide, there is essentially a virtual exchange of top quarks. It's a fusion of gluons when the Higgs is produced, and this is the decay mechanism. Finally, you look at those protons. So here are the 2 people who finally profited from this result. This is Anand and Higgs, who finally were given the Nobel Prize. It seems now that it's already a signature that presumably there is an event which suggests there is presumably another boson of 750 GeV. This is still sort of partly at the speculative level, but I think the latest data still shows there is perhaps more meat into it. Now, this is the time I want to pause and say genius. I've heard at times people will say, oh, but why should India be wasting money on detection or spending money on this LHC, finding out whether it exists or doesn't exist? It's a very simple question to ask. Must we participate in esoteric research like gravitational wave or search for Higgs? Spend big sum of money on international participation? What good it does for us or for our society? Now, I think we need to look at India's engagement with advanced research programs in a historical context. Because you can't isolate it and start trying to answer that. And I want to spend a little bit of time. If you look at the departments like, let's say, India Meteorological Department or Geological Survey of India, it existed even in 1940, before 1940. In fact, GSI was somewhere in 1860s and so on. Okay. Similarly, IMD started much earlier. But that was because British were interested in generating something which was a service kind of to the community. It was the regular kind of research of the type even what Professor Anand was indulging in Lahore and later on here. This has been somewhat marginalized, but serious effort in the form of large-scale national labs of Government of India materialized only after independence. Initially, it was the Council of Scientific and Industrial Research, and then Department of Atomic Energy, then later on DRDO, ICAR, and so on. Now, each of these agencies followed their own path. ABBA, who was associated with DA, he decided that he'll set up only one atomic energy establishment from there, and not many labs spread all over India. This was one multidisciplinary center with an integrated research applied technology-related programs. Now, KIMR was essentially the creator of AET. So Bhaba's plans for AET actually reflected his conviction that research and technology must go hand in hand. You cannot have something being done somewhere. And I'll show you a few pictures picture because that is important. What Bhabha did was, if you require, let's say, an electronics expert, you require a nuclear physicist, you require a radio chemist, you require a metallurgist, put them under one roof. So even when you want to set up, let's say, a plutonium plant, it is not you have a chemical engineer and you don't know what to do, then you go outsource something else and then things go on. So the real strength of this model of trying to put everybody under one roof was that all the expertise could be then intertwined appropriately. As I will argue a little later, this is the strength of Bhabha's model. But equally it requires that there has to be a Bhabha at the top. If he is not able to gel all these various capabilities, and you know, we Indians in general learn to quarrel more than cooperate. So we're not bad at that. Things really don't gel the way Bhabha envisaged. So in fact, I'll share with you what in my judgment has been happening since. So this is what is my conclusion. In fact, the multifaceted character of AET with very few parallels elsewhere internationally led to an incredible range of successes. From 1954 to January 66 when Bhabha died, DAE's output was trailblazing, and I'll show you that in the next few slides. But this progress was largely due to a range of expertise available in the one. Sarabhai took charge of DAE in mid-66 after Bhabha died. He was also deeply interested in basic research in cosmic rays. He carried on with Bhabha's philosophy and enhanced it by adding more space-related activities. But when he departed, I think DAE's thinking changed. Homi Setna, who took over from Sarabhai, was a project engineer. So project engineer, you know, he puts you on a track and he kahan pahuche. Now, on the other hand, space was led by Satish Dhawan. Satish Dhawan was a person who was director of Indian Institute of Science, Bangalore. He was an academician. So their approaches were somewhat different. So you can see that although space and atomic energy was, you know, sort of left in the lurch, if you wish, after Sarabhai's death, their trajectories have been slightly different. So I'll share a little bit of more of my impressions with you. This is my personal analysis. Here is a picture, for example. This is the period, the first phase of DAE's growth. Apsara was built from May 1955 to August 1956. In 15-16 months, Bhabha managed to create its entire reactor. Okay? The only thing which we got was some enriched uranium from United Kingdom. But otherwise, everything was done indigenously, including developing some electronics which they have developed and so forth. Canada-India reactor, which was built in just 4 years, 1956 to 60, first criticality July 60. Thorium plant commenced operations in September 55 because Bhabha had in mind the third stage of nuclear energy program, so he needed thorium. Plutonium plant built in just little over 2 years, 2.5 crore budget. I've heard some stories from various people who have been associated with these projects. Radioisotope production facility built around 1960 and even iodine uptake for thyroid studies. This activity started in 1960. That is because he had some people who would be associated with radiopharmaceuticals and so forth. This is electronic production unit which was started in the 60s. Control station of the plutonium plant. This is a rocket launching facility built in 1963. In March 72, in fact, Ramana was made director of ERC after Sarabhai's death. Then became chairman AC. And space was taken over by Satish Dhawan. This is in fact the SLV-3. My friend Ved Prakash Mantas was the project director for this on its launching pad during the mid-70s. So you can see they were not practically at a similar level, but I think space managed to accomplish much more. Now, this is my analysis. What I think is, over the last 50 years, DAE has built a sound base in many areas of nuclear reactors and related technology. Uranium ore processing, heavy water, fuel fabrication, spent fuel processing, etc., etc. Lasers, accelerators, advanced electronic systems, and also spearheaded cutting-edge research. I would say reasonably successful. Okay, CV. And similarly, Department of Space has developed launch vehicles, built satellites, both for research goal as well as civilian application, and created telemetry, navigation control of space instruments. In fact, that Mars orbiter mission, if you remember, even Modi complimented them. And there have been international compliments because it is subtle technology. You get a time window of barely a few hundred milliseconds within which you have to make your move, otherwise you lose the mission. If, this is my punchline, if the nation hadn't invested in these R&D projects, we would be lagging behind in our technical advancement. So the real gain from the pursuit of R&D programs is that we acquired an ability to overcome technical hurdles. Remember that there was this cryogenic rocket technology. The Russians said, "Nahi denge because the Americans won't." A few years down the road, we have our own technology. It is because there is a certain self-confidence that people have. So to me, the most important thing is that we acquire an ability to overcome technical hurdles. If we tap this strength, we can create a high-tech industry or jobs at home for our high-quality manpower, and that should be the aim of making India. Not you get somebody else to say, okay, some older technology will come and set up a shop here. We should not be a workshop for others. We have the ability, we should be willing to take up additional challenges. So we must look at our education, research, technology development, industrial progress and commercialization, job creation and seamless activity, where all facets must dovetail, especially to meet societal needs. And I'll show you through a few examples, okay, how a robust effort at home in advanced program is key to our success. So I'm sorry, I need to hurry up. So this is the light source with which I was associated, so I will not spend more time. I'll only tell you what are the things which we have done. These are some pictures of the Indus 2 which we had set up at Indore. And it was inaugurated by Manmohan Singh way back in 2001. In fact, 17th December, when we did make it at time. Indus 2 dedicated to the nation. And Manmohan Singh was very sweet because he wrote this in our visitors book. Modern science and technology have opened up enormous opportunities for human development. The Department of Atomic Energy has been a pathfinder in this regard. This is a tribute to leadership provided by people like Anand. Because he was the same day he was renaming CAT as Bharat. And these are some of the visitors from overseas. This is Director of Fermi Lab, Pierre O'Reilly. This is Barry Barish, who was the director of that International Linear Collider. This is Albert Walker, who was the director of JC. Okay. This is Jonathan Gotham, who was director of SLAC. This is the person, Kurokawa from Japan. This is Bob Kepper. This is my friend Shekhar Mishra, who was Bharadwaj from SLAC. So I want you to notice this. This is what Pierre O'Reilly wrote. It has been a great pleasure to visit your facility and to learn about your laboratory and your many skills. The light source Indus 2 is highly impressive. The spirit of being in command of all the aspects of accelerator technology is commendable. The many young people we saw on the tour also tells us of the strength, and he says the future will be bright. Your spirit of international collaboration opens up many opportunities. So he said he will now look forward to working with us. So in a way this helped us. Once the king saw that strength and said, okay, why don't we shake hands? And that is how our collaboration with this was on the American side involving Fermi Lab, Stanford Linear Accelerator Center, Thomas Jefferson Laboratory, and Cornell. And on this side we had all, it was RRCAT, ECC, IUAC, AIFR, ERC, and the university. There were some strategic reasons. Similarly, we wrote some data out of it. Now, what has happened is this DAE Fermi Lab collaboration initially was focused on some value engineering of this ILC. But our engineers went to Fermi Lab, identified where they can contribute and so forth. And I'll show you a few pictures how we learned how to make offset cavities and so forth. This is some hardware which can set up facilities at Indore. who are now participating in this Indian institution for Milan collaboration are involved, BRC, BCC, IUSC. They have developed lots of subsystems which have been tested at Milan. I'm sorry I have to rush through a little bit. They have already started making for this proton experimental injector experiment. And hopefully this should enable us to get into high intensity proton accelerator. So this is some hardware which has been sent to Fermilab. You can see some of the things which have been sent. And again, some magnets built by people in DRC. The mesh tuner built at DRC. And this gladdens me, because this is barely a 2 days old email from Steve Holmes, March 23rd, where he says, it's a pleasure to tell you that we successfully accelerated the beam. Okay. Following the exit of the Renac 4 quadrupoles and 2 corrections manufactured at DRC, once the quadrupoles were energized, the Faraday comes downstream, the transmission is social. So it gives a certain kind of confidence. If you make something, it is qualified in a laboratory like the best laboratory internationally. We have actually strengthened the confidence of people that we are on the same leg. This, in my view, is the most important. I'll switch gears again and share with you something about why I think if we can suggest to our scientific community that let's look at also some practical applications. So I want to dwell on this medical imaging because there are a lot of future physicists in Panjab University. We do a lot of stuff with IUAC and so on. Basically, it is just some gamma detection. So if we can do gamma detection for that, why not single photon emission computed tomography, which is based on again detecting gamma rays emitted by a radioisotope using a scintillator and a or a positron emission tomography, which is based on detecting gamma rays sequences. Okay. Now, the thing is, even the radiopharmaceuticals which are needed, they can also be prepared with it. It's a question of putting our act together. Now, it seems to me it is because different people are distributed in different places. But I was actually suggesting to Arun some times back that Chandigarh is a good place because you have PGI next, and there is a certain core strength here. You are anyway going to build some put in an accelerator. So keep that at least at the very least as a possibility. So these are some of the radio tracers which are used and which are the imaging organs. That's a schematic. Basically what is done is, this is the organ which is, once it has a particular radioisotope which has been picked up, it emits gamma rays, so you essentially have a scintillator crystal, photomultiplier tube, and finally some kind of electronics. So these are pictures. For example, this is a SPECT imaging of a patient who is suffering from Alzheimer's. The arrows indicate which is the place where there is a deficiency in blood flow because of the disease, and that tells the physician what is the remedial measure. Similarly, this is for cardiac perfusion. This is the lower pictures are when the person is at rest, and the upper one is when he is under stress. The upper curve is. You can again see which are the regions where there is a deficiency of blood flow and stuff like that. Now, the moment you have that sort of a facility, then people will see direct benefit. You can say, भाई ये देखो इसलिए हुआ है कि ये हमने किया है. अगर हम हमारे लिए रिपोर्ट करके करेंगे, many of these facilities are available, but it's at a price tag which is huge. So it cannot make it accessible to everyone. So I want to, in fact, skip through this. In fact, the Radiation Medicine Center in DRC has been making this fluorine-80 for this PET imaging. And I'll show you just one picture of how you can utilize this PET imaging. Today there is even this kind of interest that in Navi Mumbai, there is a guy who has imported a cyclotron. He produces these fluorine-80 and he sells it to nearby hospitals. But the country is huge, so there are many more which are needed. You know, it costs, let's say, something like 10 crores or upwards of that amount. If you are doing it through homegrown effort, it will be much simpler and cheaper. Now I want to switch to the last thing. And there's a reason why I decided I'll talk a little bit about our synergy. What you will skip through the next few slide is we have very lofty projects, programs. We will have so much of wind energy, so much of solar energy, and so on. But there are so many issues because these are not trained physicists who are at least all the time looking at all the facets of a problem. And then say, भाई अब कुछ देख रहे हो ना? ये बंदा could have said कि उसको देखा तुमने, उसको देखा इलेक्ट्रॉनिक्स में, he would not have said कि अच्छा चलो तुमने वो emulsion लगा दी काफी है. Now, if you have to take that data, whatever is that track created under your microscope, have you made sure that the right magnification are there and so on? So it is that elaborate test which we communicate during our training to students. That is missing according to me. I'll sort of just elaborate on this why I am mentioning this. If you look at the evidence today, it is not speculative. The evidence points to global warming. Since 1880, the temperature rise, it has been steadily increasing. Today it's of the order of over 8 degrees Celsius. Till 1980, this is only about a third, and after that it has risen very rapidly, and then the Intergovernmental Panel and so on, India also has a representation of it. And if you look at any good physicist will tell you, here the slope is much smaller, here the slope is much larger. So it is incontrovertible. You can keep squabbling about it, itna nahi hai, itna hai, that is different. It is the concession, so many ppm or little more, little less of greenhouse gases, that goes. And there is a Goddard Institute for Space Studies in New York City. They have created this map, which essentially says which are the warmer regions as compared to the decade, 1951 to 1980, in the last 10 years. You can see there is a lot of global warming. All this extreme warming is shown in the red color. And blue are the regions which are a little colder. Warming is much more. So the question is, what should be done? Now, India has been talking about an energy, we have always been energy deficient. But if you use fossil fuels, they cause greenhouse gases. So we need alternatives. And unfortunately, the uranium resources are meager in this, so we have to accelerate our third stage of nuclear energy program, which is built around thorium. Of course, Fukushima events have caused a lot of concern whether nuclear energy is the right option, but nevertheless, as a portfolio, we should still keep that in check. Now here, I'll just take 2 minutes to tell you about what is the challenge in thorium. The thorium per se is not a fissile material. You have to convert thorium-232 into uranium-232 to essentially a neutron capture and a beta decay and so forth. Then you can utilize U-233 the way you utilize U-235. And I'll tell you what is the benefit of it. And you can either use it as a new fuel or something like this. Much greater abundance of thorium, its superior physical and nuclear properties, better proliferation resistance. And if you can have a neutron source, like an installation source, then you can actually increase the generation of uranium-233. That is the rationale. And the essential advantage of thorium is the following. If you look at the number of neutrons which are released in a fission, a certain number is necessary for the fission of one of the atoms, and you have to replace the one which has been consumed. So this excess number nu is which can be used for breeding the material. So you can look at this blue curve, which sort of leads this uranium-238 based plutonium. You can see that U-233 gives you better breeding compared to even plutonium-239. That's the advantage of uranium-233. But the problem is there are lots of challenges in this. The biggest challenge is this. In the thorium cycle, there is also a uranium-232 which is produced, and I have written down some nuclear reactions. And if you look at the decay chain, uranium-232 ends up with thulium-208, which produces this hard gamma emitter, 2.6 MeV. That hard gamma makes reprocessing extremely complicated. So, what is the way out? The way out is, if somewhere you can, in this decay chain, one good thing would be radium, for example. If you can sort of remove from the spent fuel, when things are decaying, you have 1.9, and that is the half-life. If you can eliminate that and take it away, then it is outward, then you have essentially truncated this decay chain right here, and you can take it separate. So this is essentially, there are some ideas that people have floated at Trombay, but they haven't really worked. So ideally one should involve some chemists and figure out how to remove radium out of it and so forth. And I want to share with you what the Americans were good at. This is a reference which I would urge you to look at, nuclear science and engineering. Because it refers to Oak Ridge National Laboratory had a molten fluoride fueled aircraft reactor experiment. The intention was nuclear energy is very abundant in energy. So can you actually have a reactor finally as the source of energy to propel an aircraft? So they did that experiment and in fact even showed some interesting results in which a uranium-thorium mixture, such a thing could be operated. Finally it was converted into a civilian application. And unfortunately Weinberg had a tip with Nixon and he sort of tapered off his program. Oh, if you don't know the boss's line, you can get killed. But this is one avenue which I think is worth picking up again. Now, of course, this is the trust in this country. You will use wind and solar energy and generate 100 gigawatts and so on. But it is, you can see here, every year about 40-50 gigawatts are generated. This is the kind of, how the consumption has been happening. This is the part which is wind energy, this is the part solar energy, partly because the prices are falling. And this is India's projected program. We claim that from 5 megawatts in 2008, we will hit 20,000 megawatts by 2020. Now we said that in 2008, then 12 years was far away. But now that we are in 2016, our number is still about 5,000 megawatts. You can't go from 5 megawatts to 20,000 megawatts, a factor of 4,000 in 12 years. Okay? That is because you are doing some arithmetic on the basis of some management skills and so on. So this is the tragedy. And similarly, if you look at what is our production capacity, what kind of solar capacity we have created. Solar capacity, even today, we match nowhere. This is India's solar capacity. It's about 500, 600 megawatts. And even the Malaysians are doing better than us. The Philippines is doing better than us. So somebody has to be sensitized that something is not right. It is not an exercise. I mean, maybe our energy minister is very crafty. He can figure out how to manipulate the right kind of policies. So, if you look at it, how can you reach now? You say we will get to 20 gigawatts. That was last year. Now you say 100 gigawatts by 2022. तो कोई arithmetic तो कर लो. उससे होगा नहीं होगा. What is the thing which is missing? These are the numbers which I just now mentioned to you. Similarly, wind energy. Wind energy, our current installed capacity is something like 25,000 megawatts. Okay, and people have done some studies. This is the Center for Wind Energy Studies, nominated by engineers. They look at what is the wind power density per square meter, and calculate what is the area which is served by the rotating blades and so forth. And some numbers have been generated. I'll show you that table. Something has been said if you tap energy at 50 meter height versus 80 meter height. So Andaman Nicobar, that number may be not 2 megawatts, it can be 365 megawatts and stuff like that. So a lot of numbers are generated. The only thing which is interesting here is to look at, for example, Karnataka. It says instead of 8,500 megawatts, you can get 13,500 megawatts. I don't know whether it is true or not, but Tamil Nadu, that number will be instead of 5,000 megawatts to 14,000. These are the kind of numbers. Instead of 49,000 megawatts, we can get to 100,000 megawatts if we tap the energy at this time. Wonderful. But is this the full solution? And I will share with you what are the problems connected. See, this is some study which has been done in Minnesota. Okay. What they have done is, this is the load on the grid. This is what the grid was capable of generating. So there are days in which you get good wind, okay? Because it produces good wind, so you can see the difference. This blue color is the difference. This is the load, so the load significantly comes down, okay? Similarly, but there is a day like here, there is no wind. If there is no wind, well then you are stuck. Where from are you going to meet? So your total load continues to be exactly as it is. So unless you have a backup plan, हवा नहीं तो क्या करोगे? Now you can't say, okay, I have built that, and you are going to then ask industry to shut down on a certain day or something like that. You are not going to have some operation in a hospital. So I think it is this part which I at times worry. So people have asked this question, can I predict what would be the, just as you have a weather forecast, this would be the temperature rise. Can I predict what would be the wind pattern in a particular area? And there is a lot of refinement which is necessary. Because you ask a physicist, he will say, let me write down the hydrodynamics equation. Let me worry about whether altitude is playing a part, temperature is playing a part, pressure difference is playing, and so on. So there is a lot of modeling, etc. And I think if we can entice our younger people to say, look, this is something which needs to be looked at, that would be a service to the country. There is an alternate thing which people have explored. What they have said is, if the total region which is covered by the grid is large, then यहाँ हवा नहीं चलती तो कहीं और चलती है. There is sort of, you can do some kind of a compensation. And this is similarly for the solar energy in Germany. Again, there is a huge swing. Someday there is no solar energy, then what are you doing? So the Germans have come up with a plan. They tell the nuclear power stations, if we are generating enough solar electricity, you can trim down your power generation. But then the nuclear power station operators complain, "Arey, हमारा station अच्छा चल रहा है, why did you suddenly ask us to shut because?" So these are still sort of issues which are thorny, which are not very well analyzed. And the only solution is you should have large energy storage systems. So the energy storage, this is again a huge amount of research which is needed. So what is indicated is what is the total energy. Would you have a power outage for 1 day, 1 hour, etc.? And what is the kind of power which you will require? And there is a huge portfolio of what are your options, including, for example, this is synthetic natural gas, hydrogen, or compressed. This is compressed energy, and so on. I mean, batteries and so forth. And one of the good things is this redox battery number, which is RBL. Again, interestingly, some companies in America are actually getting into this redox technology and selling it to our customers. But I think we need to do something about it. So let me wind up then. I'm sorry I've taken more time, but my idea was to sort of still give you a flavor of everything. Cutting edge research is essentially a stimulus to inculcate creativity. And I think it is vital for any society that wants to. If you don't inculcate that creative thinking, there is a penalty which you are paying. Whether it is in the form of your business being taken away, your jobs being taken away, or whatever. Now, financial gurus and management experts can certainly help how you manipulate money and so on. But they can't replace, they can't be substitute what can only be realized in scientific research. I think this is in the upper echelons. I mean, today there is a preponderance of this kind of idea. Some there is separately. No, we have made this one. अरे भाई तुमने उसकी फंडामेंटल तो उसको तो ध्यान नहीं दिया. What plan are you talking about? So the question is, pioneers in India's science and technology sector would have liked us to continue to our R&D, add to our R&D efforts, and focus on programs for the benefit of society, so that India's citizens too enjoy a decent life. See, what has happened is they say, oh, you are interested in owning some piece of credit. So time has come that we show our value in it. And it is not that we are not interested in looking at that kind of stuff. Perhaps and we would have closed all the escape routes for these guys. So hopefully, Panjab University, especially the physics department, because that has been its tradition, will take the lead and become a leader
Thank you very much, Dr. Sani, for a very informative talk and deliberating how small-scale projects, starting from 1905, rolled into the extreme engineering projects by the end of the century. Thank you once again. We can take a couple of very urgent questions.
What was very instructive. You covered a lot of topics, while my comments are only on those portions which I think I understood. The first point I wish to make is a chronological record. Before 47, 5 CSIR labs had been set up, as well as PRL and PAR. Of course, they took off only, but that is, you made a very interesting point about the fiscal pressure. Like fund givers asked two institutions in US to collaborate, work together. And you also mentioned fiscal reviews telling Einstein that your paper will have to be refereed. I would like to ask you, I think I know the answer, but I would like to still ask you the question. Do you think such things can happen or would happen in India? But let me finish off so that I don't. You also mentioned, for example, Ranjan Gupta's email to you, and if you hadn't retired, if you were in office for another 5 years, probably the course of events could have been different. And you also referred to Baba's leave as well as Vikram Sarabhai's period, and then you hinted that once they were gone, at least in DAE, we reached a plateau, if not. Now that is a very important question, and that question is, how significant should the role be of individuals in institution maintenance? That's the point. The last point which I would like to make, there's another point. You mentioned the Higgs as well as gravitational wave, and we were very proud to see the coverage, Indian contribution in these two projects. But then I also looked at the coverage of these events in the Western world or rest of the world. So there was quite a bit of mismatch in the sense कि जो हमारी फिल्म जिनको हम फिल्म का हीरो समझ रहे हैं, उनका रोल इतना बड़ा है नहीं उनके वे. तो I would like you to comment on, since they are international projects, so the assessment of the role played by different teams can it be so different, or is there an element of patriotism which goes beyond realistic terms? And the last point is semi-philosophical. See, as scientists and technologists, we overestimate the role which technology can play or should play. I think very often the solution to a problem lies in retreat from technology rather than advancement of technology. So I would like, as a technologist, I would like you to.
Thank you, Rajesh. But I would have to give another talk if I could answer all your questions. But let me, because you have mentioned many things. Let me begin by first answering your point. You are right that Council of Scientific and Industrial Research was conceptualized in 1942 during the war. And in fact, the foundation stone for National Physical Laboratory was laid in 1946. So in that sense, it predates independence. But I was not making a legal argument. It was more in the nature of the spirit. And I was saying that largely, this culture of national laboratories, doing something holistically, this is a post-independence phenomenon. I mean, I don't think we can really quibble about it too much. There is no question that individuals will play an important role. I mean, if Baba, simply by the charisma which he had, Pandit Nehru simply by the charisma he had, would influence events much more emphatically, okay, or Abraham Lincoln and so on. Now, America has had almost 50 presidents. So the effect would be different. I mean, this is partly because it's a sociological issue. It is not a scientific or technical issue and so forth. To completely immunize an institution such that whoever is at the helm of affairs, I mean, Arun Grover is the vice chancellor. He is sort of supercharged with trying to do this. Okay? Is there something he can imprint into this DNA of Punjab University that legacy is carried forward? He can attempt it. He may succeed, he may not succeed. So I would say that here, over a period of time, it is a cultural issue in which the society as a whole has to address that. Okay? Now, I was alluding to the point that because there is a different way of thinking about a problem, if I am a project manager, I have no problem with the way Setman took his decisions. I can share with you about this. Vikram Sarabhai was talking about 500 megawatt, 600 megawatt station, even in 1970. Okay? And Setman felt he has his head in the clouds because even that 200 megawatt Tarapur reactor, suddenly it switches. There is the power grid cannot tolerate a 200 megawatt disruption in power. Okay? So he said, the country is not ready. So he actually put 500 megawatt, 600 megawatt stuff in the food schools. And people realized it only after M.R. Srinivasan took over. Okay? In 1987. So in 1990 or something, then people dusted it up. If you look at the money involved between 220 megawatt versus 500 megawatt, any day it would have been much more sensible. But after 500 megawatt, now NPCL is saying 700 megawatts in 90. Now, all I'm saying is the research-oriented person perhaps keeps his eyes on many more things. On the other hand, a project-oriented person, and let's be clear about one thing. Supposing I have a project to lay a new road from Chandigarh to Delhi. I know what are the ingredients, I know who are the contractors can do it, not do it. So if somebody who knows how to, build this thing, obviously will be more successful. The flip side is even sir, the person who preceded Robert Hema, who was the director general, was a Italian professor. He was sort of laid back, sort of more accommodating, he has so circumstances was very unhappy. But Robert Hema, I think, pushed some of those things to a slightly beyond the limit, which is why that problem in September 2008 accident happened. Because he was hurrying up everything. So it is not as if it's exclusive domain of India. I think there is a human psychology involved. What happens is, as a society becomes more mature, okay, you have differences of opinion. Just as you and I can have differences of opinion. But then we figure out what serves the interest of the institution or country or whatever region best. I think we have not been independent enough for a longer period. So perhaps, whatever you see as newspaper headlines, in fact, I had a stick to wheel. I would say whatever is around media is not adding any value, it is only subtracting value. Okay? But nobody will accept that sort of distribution. So I think we simply have to sort of suffer the pain. Hear it for a while. Pray to God, hopefully we will get out of it. I think overall one can be still optimistic. Because if people come from outside, they still say, yeah, we are not in that. Anyway, Zindaji had a question.
Yeah. During the last part of the talk, you talked about energy which is weather dependent, for example, wind energy and so on. Can we have some efficient storage of energy possible apart from batteries, of course? I mean,
That is a very, very important question. Because I think therein lies the crux of the matter. Now, in the very limited time, I was merely interested in flagging that issue. Suppose I am talking of a helmet in which there are some 5,000 houses. And I assume that on the average they take about 3 kilowatts of power. Okay, so I can estimate this. And itne ghante jo hai power outage रहेगी. Mind you, I refer to the Americans are in fact at cashing on our market. There is a problem that a lot of these communication towers, there is a power outage. Power outage, therefore they have to put diesel. और फिर diesel चोरी हो जाता है. So all sorts of problems. So this redox flow batteries, they have generated, it is 30 kilowatts. It can work for 4 hours. Okay? Now, a redox battery is just that you have not an electrode. Ultimately, the surface area determines what is the total capacity. You take your car battery, 12 volt, 50 ampere hours, it's only 0.6 unit of electricity. The units humongous. There, in the redox battery, you finally have it in the form of ions which are somehow created. They are stored in a separate tank. Bring it essentially to the electrolyte cell and so on. Now, these adaptive solutions have to be picked from that last slide which I had, last slide. Okay. Depending upon what your requirement is, you may discover that yes, if you are talking of something which is 10 kilowatts, 20 kilowatts, which has to be catering to for so many hours, then this is a valid solution. Maybe even the lead accumulator is good enough. The lithium-ion battery, Tesla is wanting to come and sell those electric cars here in India. There are some news items because Modi ji गए थे वहाँ पिछले साल. तो भाई आप ये सोचो कि लिथियम जो है कितना हमको चाहिए होगा? हमारे पास है. So even these are questions which one needs to ask. I don't have any solution. I was merely sort of raising a flag and saying that these things must be. I mean, you and I, it would come spontaneously because that is the trajectory we have gone through in life.
I have a very simple question. You talked about global warming and the temperature rise in the global warming was much less in the earlier time than what is taking place now. The rate. The question which I want to know, if there is any answer, how much is the contribution from thermal burning and how much is the contribution from the radiation side? That's the question precisely.
See, ultimately, if you attribute any rise in temperature, unless you can partition it into various sources, you don't know whether you are going to apply the right quantity or
You
not.
are going to control it or not, yes.
Absolutely. So the thing is, I don't know enough about it, but there is a fair amount of research which people are doing. And I can also tell you something, even this kind of experiments people have done. You take a tree. Is this tree itself, because it's a living object, how much of carbon dioxide it is consuming, not consuming, and so on? What are the kind of pollutants inhibiting its activity and so on? And people are doing such kind of experiments. Essentially create some kind of a greenhouse around it and monitor it with very, very sophisticated things. So people are alive to this issue. Now whether you can put an animal separately, because even the living animals, they say that belching itself from cows can lead to this. So this is a very relevant question. I am not competent to answer that, but there are a lot of people who are looking at that kind of problems.
You were telling us about that Indian government has also commissioned plan for gravitational observatory. So the technology which would be needed in that observatory in India, and so where would the technology and the instruments that are required come from? Would it be from USA or would it be developed indigenously in India? Do we have that information?
No, I must compliment you for raising that issue. See, the thing is, when in 2009, in fact, Professor Kochar referred to that, in 2009, when India's participation in Australian International Gravitational Observatory, that idea was mooted. I said, yeah, हमको बाहर से थोड़ी खरीदना है, कम से कम यहाँ पर आके look at people. So it may turn out you require a steel which is about 2 meter diameter. Okay, you require, let's say, 4 kilometers long. The demand is that the hydrogen outgassing out of it should be below a certain threshold. You should be able to reach a vacuum of 10 to the minus 8 ton or whatever is the number. I think the best course of action would be we should say, look, we will not import it from America unless it is absolutely compulsory. Unfortunately, what has happened is many of the torch bearers in this, again it could be some secretary sitting somewhere making a decision. There is a 1300 crore, थोड़ा ऊपर नीचे होगा, उसको we will adjust it later. I think this issue will not be confronted as honestly as it deserves to be confronted. But you are absolutely right. I think we should first ask this question. Yes, but that vibration isolation systems, I would suggest website. That's a website which is called Caltech runs. And you will be thrilled to read it. Yeah, I have some supplementary slides I can show you. I mean, even to design that vibration isolation, first you have to figure out what are the sources of vibrations in the right frequency range from something like, let's say, 10 hertz to 10 kilohertz. Okay? How do I link this noise? And I mean, it's fascinating to read just that stuff. So if we find that that is very, very difficult to accomplish on a realistic time scale, then okay, we can still procure it. But we should not lock, stock and barrel pick up everything. This would be my suggestion.
At the moment, only the detector is supposed to come from there and everything else is to be done within India, in the vacuum. No, yes, I was in a meeting yesterday where this thing was discussed at some. And people from RRCAT, there were people, all the LIGO people were there from IUCA, from TF and ISC, and the DAE secretary and the DST secretary were both there. And lot of things are going to happen indigenously. Okay, now, it's not that something will come and it is to be restored. Huge amount of research has to be done just to get that done.
मतलब क्रिएटिव थिंकिंग के लिए मतलब प्रमोशन करनी चाहिए और उसके लिए स्पेस भी है नहीं ना हमारे स्ट्रक्चर में। जैसे आप कुछ चीज़ें चल रही हैं सोसाइटी में उसको देखें तो कि ड्रॉप आउट रेट 12th के बाद 90% है और बिलो पॉवर्टी लाइन काफ़ी बड़ा सेक्शन इंडिया का है। और अभी जो इकोनॉमी में चल रहे हैं चेंजेस की एजुकेशन से फंड घटाए जा रहे हैं और इतने सारे इंस्टीट्यूशन की फीसें बढ़ रही हैं, तो उसका भी कुछ रोल होगा ना कि सरकार को एक स्पेस तो प्रोवाइड करनी पड़ेगी ना जहाँ पे डेवलप होगी साइंस।
You are asking again a very relevant question. I think one has to figure out what should be the priority of research. I can tell you one thing. When I went to Delhi University to do a BSc honors in physics, my tuition fee was 15 rupees. Fortunately, I got a scholarship, so that used to take care of that in my stay in the hostel. But our parents, they were essentially raising 5 children, and to make all of them go through education. Okay, and similarly, my Masi, my cousin is here, Dr. Shobha Segar. That was practical because the government of the day was enlightened enough. I mean, 15 rupees was not a small sum of money in 1961. But the thing is, the government of the day was still enlightened enough to set apart extra money into it. What has happened is, the political class has figured out education is necessary. So they have sort of retracted from it, and which is why it has fallen into private hands. If that was, if I had any free will, I would say, no, forget about everything else. Several other things can be given a backseat. But this is an international sort of free market economy which operates like that. The latest I heard was that IIT fees, for example, has been raised from 90,000 to 2 lakh rupees. And the year after, I would have thought a more sensible approach would be you tell the corporates, you get your research done at IITs. Okay? So if there is a mismatch between the funds needed to run IIT and what the government of the day can afford, then they should not hike the tuition fee. That may essentially price out the IIT education from the reach of the country.
I think we mark so many parameters. I think if we put the question, which my thinking is directed to one side only, that will not solve the problem. Because whatever you are saying about, you have mentioned about the fees from 90,000 to 2 lakhs, but we have forgotten what are the parameters, what are the clauses which are there in the decision. It's not that everybody has.
My point was different. What I was saying was, the decision makers have to have the right priority. Okay? To me, this is something which should not be neglected. Health and education. Why? If you look at our statistics, in some way India does not much better than Sub-Saharan Africa. Let's say just because of value. I can say it only in Punjabi. I saw all ऐसी progress. So that's a question which, I mean, you look at it from the Prime Minister's point of view, maybe he has some priorities. But an ordinary person will exactly read the question.
See, that's what I said. That's what I said. That we are having only one directed intention or to thinking. There is a person who is at the helm of the affair. Maybe the BC, and let's take the case of BC. He cannot think of the 6th department only, he will have to think of all the 60 departments.
But true. But the fact is, a person like Amartya Sen, I think this is a private discussion.
Yeah, that's what I'm
Amartya Sen, this is exactly his limit.
Dr. is going to be around today and tomorrow, and discussion with him and interaction can be had later. We would like to, as a token of gratitude, present a memento to Dr. Sani, and I would request Professor Grover to do the honors.
Let me present you a few books. Okay, so this is the biography of Pyara Singh Gill, born in 1911. This is reprint of Nora Richards' biography of Patnanik, born in 1984. This is Salam, born 1926. And this is the contemporary of Salam who didn't do physics but did geography, Professor Gurdev Singh Rosa. There is a deep connection between all these four. You can enjoy reading it and connecting. Thank you for giving me this. Thank you.
Thank you, Dr. Before I propose the formal vote of thanks, I take this opportunity to invite Dr. Anand, representing the Anand family, in case he wants to share his present of family with us. Dr.
Thank you very much. Thank you. Professors Grover and Mehta, and thank you for the illuminating questions and a very gracious welcome that the Anand family and our family has received. Today is a particularly auspicious day for me. We are commemorating the legacy of my father-in-law, who, as my father-in-law, and the honor of presenting the talk went to my brother. How much better can it get? I remember my father-in-law, whom we used to call Baoji, with great affection. Towards the end of his years, he came to live with us, and I was very impressed. Even to the end, he retained his unique curiosity about everything. The spirit with which he proceeded to do his research, he carried with him throughout. He was thrilled when I enrolled in the law school. But I will give you one glimpse. He was not able to go up and down, and therefore he wouldn't normally sleep in the bedroom. He used to sleep downstairs. We had set it up for him. But one day he was trying to go up, and my husband went and he said, "ਤੁਸੀਂ ਕਿੱਥੇ ਚੱਲੇ ਹੋ ਜੀ?" bedroom ਵਿੱਚ ਬੱਚਿਆਂ ਨੇ ਕੋਈ ਨਵੀਂ computer game ਲਿਆਂਦੀ। So he go and play with that computer game. He was close to 90 years of age, and he still wanted to go and see what that is all about. That is the spirit that we need to inculcate. There has been some discussion about the difference between the West and here in education. Why is it that we are not able to create the kind of circumstances that the West has created? Well, they have many more resources, I won't deny that. There is no dearth of talent in this country. I came to live here for a year with my kids in the 80s, and I noticed that a small 6-year-old boy who was collecting spare papers, he would just pick them up to help his family. He's going all over the yard. And he was doing calculations like this. I've never seen even high school kids in the US do calculations that fast. So there is talent. People who go from here often do extremely well when they go abroad. There is a lack of resources, but there is also one particular modus operandi that I think we need to learn from the West, and that is right from the beginning there. Our kids were educated in that country, so I noticed right from the elementary school, the kids are taught to work in teams. Everyone, even in a small, in 3rd grade, 4th grade, is expected to do a project and put together a team and they work together. That is a difference. I do not know if that is done here now, but if it is done, great, I'm thrilled. If it isn't, that is one thing that we need to emulate. Moon landing, the Voyager, LFC, this kind of projects cannot be done by an individual. They have to be done by a team. The team has to function like one person. And that is the important thing. That is the important lesson that we need to learn. The subject matter that my brother spoke about, one, it's a collection of things. I am very proud that he is able to present it. Some of it went way beyond my capability and knowledge, and I'm ready to salute him. But I must salute also the Department of Physics and Panjab University for giving me the honor and giving us the honor to make this happen. So thank you very much.
Dr. Indu for sharing your fond memories with us. Before I pose the formal of thanks, before we close, once again I would like to say with regard to this function that memories are unending, memories are evolving, and memories are energetic. So we would like to extend thanks to Anand family for being with us today, and we hope to see them year after year here for the same lecture. I would like to extend thanks to Dr. B.C. Sani, who has graced the event and shared his views and concerns about the goals of the physics community and society at large. I would also like to thank Professor Vice Chancellor, without whose guidance this function would not have been successful. In the end, on behalf of the Department of Physics, it's a great honor for me to thank all those who contributed in the organization of this function to make it a success. Thank you all for being with us and sharing the bliss of this occasion. Thank you once again. Goodbye, and hope to see you next year for the third year on our program. All invited guests, I can see, are invited to join for lunch with the